Okay, so I want to do a video for calculating the reaction rate of one reactant from that of another. All right, so thank you. Can you take that spoon? I'm going to do this in my kitchen here, and the windows are open. The day is too pretty, so there's going to be a little bit of background noise. Plus, my children are here with me, so just bear with me. All right. So what I've done is taken a snapshot of this page and put it over on my whiteboard. So I'm going to have to go back and forth a little bit. That might be a little confusing. So first of all, let me read this question, and we'll decide where to go from there. The reform reaction between steam and gaseous methane produces synthesis gas, a mixture of carbon monoxide gas and dihydrogen gas. All right, so that sentence is probably just a throwaway sentence. We don't need it. Synthesis gas is one of the most widely used industrial chemicals and is a major industrial source of hydrogen, which is sort of interesting, but we don't need that either. Oh, you know what? This tells us our balanced reaction, right? The reform reaction between steam and gaseous methane. So yeah, I do want to write that down. Okay, so let's come back over to our whiteboard here. Same question here, and I'm gonna write this down. Steam and gaseous methane. So let's disappear that. Steam looks like this, right? Plus gaseous methane, which looks like that, produces, and what was it? Produces synthesis gas, a mixture of carbon monoxide gas and dihydrogen gas, CO and H2. Let's go back over here. It was carbon monoxide gas and hydrogen gas, which Alex is being really easy on us by reminding us it's dihydrogen. Okay, make sure I got that right. The reform between steam, I got steam here. Gaseous methane, I got that. Produces synthesis gas, a mixture of carbon monoxide gas, which I have, and dihydrogen gas. Okay, I got that. All right. So it's the second sentence, which is just interesting but not important. Okay. Now suppose a chemical engineer studying a new catalyst for the reform reaction finds that 8.42 liters per second of methane are consumed. So I'm looking at methane here, and you know what I'm going to do? I'm going to set this up so I have less work to do later. First of all, I have to balance this. H2, I'm going to do H2 last because it's by itself, right? So I'll do H last. Oxygen is 1 and 1, so far so good. Carbon is 1 and 1, so far so good. And it looks like there's 2 plus 4, 6 hydrogens over here. So if I make that a 3, I'm good. All right, let's make sure we got this right. 2 hydrogens plus 4 is 6. There's 6 hydrogens over here. 1 oxygen, 1 oxygen, 1 carbon, 1 carbon. Okay, so this is balanced. Now I'm going to make this as a table. I'm going to use my balanced reaction as like my column headings in a table. You've seen me do this before. And I am going to keep my stuff organized like that. Okay? Suppose a chemical engineer studying a new catalyst finds that 842 liters per second of methane. So here's my methane, and I was just given a volume in liters, and it was 842, right? Is that right? 842 liters per second of methane are consumed when the reaction is run at such and such, 284. So 284 plus 273.15 gives me kelvins, right? And what is that? I'm going to do that in my calculator over here. Where 284 plus 273.15 gives me 557.15. 557.15 kelvins. But I do want to make a note about my sig figs. When I'm adding, right, I can only add to the ones place for my precision. So this number only has 3 sig figs in it. Temperature 557.15. This is in kelvins, right? This has got 3 sig figs for the reason I described over here. This has 3 sig figs because I'm looking at it, and it's just 3. And I believe I'm given a pressure here too. So let's see. At 0.67 atmospheres. So let's go back over here. Pressure in atmospheres 0.67, and that is only 2 sig figs, okay? So anytime I'm given this, I know I'm going to be going moles to moles, but even if I wasn't thinking that, whenever I'm given PV and T, I'm just going to go ahead and calculate moles, right? Because I know R, it's 0.08206 liter atmospheres per mole Kelvin. Liter atmospheres per mole Kelvin, and that just gives me moles, right? Okay, so if PV is equal to nRT, then N is equal to PV over RT. Okay, and so let's put this down here. This is going to equal to, my P is 0.67. My V is 842. R, and this is 557.15. Okay, so I'm going to put that in my calculator. I'm going to use my Alex calculator because I want you to see this. My Alex calculator is right here, and it was 0.67 times, it was 0.67, which is right here, times 842, 42 divided by, and if you've never used the Alex calculator, you pay attention to this, watch this. I'm going to come to my constants, and my R for gas constant, liter atmospheres per mole Kelvin, is right there. Isn't that neat? Okay, and then I'm also in the denominator is my 557. I forget what that number was. 557.15. Let's go back over here. 557.15. And that's going to give me 12.339 something moles. Okay? I store that in my calculator. I come back over here to my notes. I already forgot what it said. It said 12.339. Let's go back over here. So it's 12.339 and so on moles of methane, right? And I'm going to make a note here. How many sig figs does this have? It says 2 sig figs because it was the product of all those numbers, right? And that was limited by that. Okay, so it's got 2 sig figs. And now I'm going to say, aha, okay, if I've got my moles of methane and I need my, I'm guessing I'm asking about hydrogen here. Let's go back. Liters per second. Calculate the rate of hydrogen. That's right, of dihydrogen gas is being produced. So if that's what I'm producing is my dihydrogen gas, so I'm going to be converting that to moles of hydrogen. Okay, and so let me put my numbers in here. This is 12.339, and I have 3 moles of hydrogen for every 1 mole of methane, right? And I get that from here. My stoichiometric coefficients need those, right? This we've done many times. It's 1 to 3. Okay, so I'm going to take my number, which is still in my calculator, and come back over here. 12.339 times, already forgot it. It was times 3 divided by 1, right? Let's go back over here. Times 3 equals, let's store that number also. So it's 37 moles of dihydrogen gas. Okay. Come back over here. Equals, no, I don't want green. Go back to red. 37 moles of dihydrogen gas, right? Okay. 37 point something, right? I'll look those numbers up in a minute. So my moles of hydrogen using this table here, here's my moles of hydrogen, right? It's going to be about 37 point something, okay? 2 sig figs following that out because it came from that. That was the limiter of 2 sig figs. I think the question is asking me for what, give your answer in kilograms. How much is dihydrogen being produced, but give it in kilograms. All right, well, I can convert that to grams pretty easily by using my molecular weight. So 37 moles of H2, grams of H2 per mole of H2. That's my formula weight, right? And I can get that to kilograms of H2 over grams of H2 if I just divide by 1,000. Right? So I got to look up my molar mass of H2, which is about 2. But let's calculate this. Did I store that? I did. So let's clear that out. And watch this. If you've never done this before, I can get my molar masses by clicking this A button. This comes up, and I'm going to say 2 times hydrogen equals, and that's my molar mass of hydrogen. I'm going to store that. Okay. It's 2.016. Come back over here. It's getting a little bit busy down here. Can you read this? 2.016. So it looks like it's my 37 number, which is still on my calculator, times 2 divided by 1,000 is going to give me kilograms of H2, which is what I'm looking for. Let's go over here and do it. My 2 times, recall, there's my 37, divided by 1,000, 1, 2, 3, equals 0.0746 kilograms. 0.0746. 0.0746. But I got to report this with the appropriate number of sig figs. And so if this had 2 sig figs, this had a bunch. I'm just going to say, let's say 7. This was exact, so it doesn't matter. This is going to be 2 sig figs, okay? So I'm going to have to report this as 0.075 kilograms of H2. 0.075 kilograms of H2. 0.075 kilograms of H2 per second. All right, so hope that's helpful. I'm not going to do another example of this right now. We'll cut this video off. Let me know if you want to see another example. Best wishes.